Okay, so we're doing balancing equations, and we remember that we've got two kids on the seesaw. So algebra works like that. So we've got one kid here, and they've both got backpacks. We're trying to balance the equation. So if I take the backpacks off exactly the same time, assuming one doesn't vanish, the seesaw stays the same. The kid's now thirsty, so I give them a litre of water at the same time instantly. Again, the seesaw is balanced. So I can add and subtract. As long as I do exactly the same thing to both sides, the seesaw is not going to tip. And that's the whole point of this form of algebra. So let's have a look. If I start off with something like x plus 6 equals 10, and you can probably automatically say, sir, x is 4. That's fine, but we have to show it. So the first thing I do, I remember with backtracking how we looked at the fact that I would write x, and then I'd go plus 6 equals x plus 6. Underneath here I'd go 10, and so I should go x. Oh, actually I did that wrong, not x plus 6, that should be x plus 6 there. You get the point. Well, no, I don't like backtracking. 10 minus 6 equals 4. So technically, with balancing method, we're sort of doing this bottom piece. So we're looking for the opposite of what we did at the top. So we know it's plus 6, so we take minus 6. We know those cancel out. You put in the calculator, plus 6 minus 6 equals 0. So we know x equals 10 or minus 6. So x equals 4. Easy to see that one. If I do one a little bit more difficult, say 2x plus 3 equals 7. Let's have a look at that one. So I remember, if I go back to the backtracking, I know I start with x, I go x times 2 equals 2x, and I go plus 3 equals 2x plus 3. I put the 7 down, I take 3 equals 4, 7 minus 3 is 4. Now I divide by 2, so I reckon x is going to equal 2. So remember now, I'm doing the opposite, just the same now, I do the opposite of what's going here. Minus 3, actually I put equals between those. So I'm taking away, plus 3 minus 3 equals 0, so this side equals 2x. 7 minus 3 is 4. Now, because we know that's 2 times x, I'll divide by 2 to get rid of it. 2, 4 over 2, so x then equals 2. And that's what we looked at and we saw over here. And we can check it. What's 2? Was it equal 2? 2 times 2 is 4, plus 3 equals 7. We're on to that. That's easy. So the next part we've got to do, let's have a look at some divide ones. So we've got, where are we? So we'll do C, that can be number B, and that can be A. If I've got x over 2 equals 4. So I realise this is a divide, isn't it? So to get rid of a divide, I've got to do the opposite. And if we go back over here. And I don't use backtracking, but going off something else, spent 2 days to teach you, I may as well. Oh, it's only that one, isn't it? Not going to go that far. So we've got, start off with x, then we divide by 2, equals x over 2. We know that equals 4 because the statement says that. If we times by 2, x must equal 8. So to get rid of this, we need to multiply both sides by 2. 2's cancel out, so x then equals 8. So that's all. Now, give me a sec, I'll just see if I can show you a more complicated one than that one. Yes, I do. I'll just show you one a little bit more complex than that. So I've got d is going to be x plus 5 over 3 equals 5. So let's look at, we must remember too that this is, the vincular means there's brackets around it. So we've got to do the whole thing together. So if we did this as if we were doing this, we should have been on this. Oh, sorry, we start with x. We add 5 plus 5, and then we divide the whole thing. Divided by 3 over 3. We know the statement says it equals 5, so we've got to do the opposite here. So divide by 3, opposites times 3. 5 3s are 15. We've added 5, so we must take 5. So x equals 10. So now we're going. So let's unpack this. So the first thing we know we've got to do is we've got to times by 3. So we've got to get rid of this first. Those two cancel out. Oh, that doesn't cancel out. I know. So we know that x plus 5 equals 5 times 3 is 15. Next I need to get rid of the 5 from both sides like I did here. Those two cancel out, so x equals 15 minus 5 is 10. And that's what we got here. But let's check. So, checking. 1 marks if you did this checking. X plus 5 over 3 equals 5. So we said x equals 10. 10 plus 5 divided by 3 equals 5. 15 divided by 3 equals 5. And we see that 5 equals 5, doesn't it? 15 divided by 3 is 5. Alrighty, so hopefully that'll help. Just keep on going now with the problems. Go do 2, 3, and go into 4, 5, and 6. So keep on continuing. Next lesson we're going to go into the solving problems with equations, and we'll be finished well and truly ready for next week. So, what happened there? Oh, my thing's playing up.